Hello, everybody. Let's talk about graphing systems of linear inequalities. So, before you watch this video, if you do not know how to graph one of these, a linear inequality, I suggest you watch my video called Graphing Linear Inequalities. Once you have those basics down, then you'll be able to better keep up with my system of linear inequalities. So, here we go. So what we have with a system of linear inequalities is instead of having one inequality, we have two. You can even have three, four, five, however many. So it's multiple linear inequalities. Now, very, very easy. Here's what I'm going to do. I'm going to take that first inequality and I'm going to completely graph it and shade it in blue on this graph. Once I'm done, we're going to ignore it completely. I don't care where the shading's at. I don't care where the line's at. Nothing. We completely ignore it. Then, in red or any other color is what I would recommend for you, I'm going to graph the next linear inequality on the exact same graph. So it's really like doing two of these problems on the same graph. That's it. Okay? And then we'll talk about what it looks like once all of them are graphed. So, first one, y is less than negative 1/2 x plus 3. So I'm looking at this. First thing I see is I see this inequality, and I know we're going to have a dashed line there. I can see my slope is negative 1/2, and my y-intercept is 3. So if I go on the graph, go up to 3 and put a point, and I'm going to start doing my slope of down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. So there's my slope. There's my y-intercept. I'm going to use my D here, line them all up. And remember, we need a dashed line here. Dashed line. So here we go. A few dash marks. Great. Only other piece I need is remember our shading. So took care of the dashed line, took care of the slope, y-intercept, shading. So 0, 0's on bottom. So if it's true, I'm going to shade towards the 0, 0. If it's false, I'm going to shade away from the 0, 0. So we're plugging into y equals negative 1/2 x plus 3. If I plug in 0, 0, I have 0. Negative 1/2 times 0 plus 3. Clean this all up. 0 is less than 3. So looking at that inequality, I have to think true or false, and this is true. So since it's true, I'm going to shade towards 0, 0. Now one change I'm going to make is I'm not going to make this real dark. I'm going to shade everything below with the 0. I don't want to go crazy because I'm about to graph something else on here as well. So just a little lightly like that. That's the first inequality down. Dashed line, y-intercept, slope of negative 1/2, proper shading. True, towards 0, 0. If it was false, away from 0, 0. Put my blue pen down. I'm now ready for my next inequality. Completely ignore all points, shading, everything on here. We don't care. It's a completely new problem. So y is greater than or equal to 3x minus 4. I see that inequality with the equal to. I'm going to have a solid line. My slope, 3. My y-intercept, negative 4. So I'm going to come down to negative 4, put a red point. My slope of 3 means I'm going to go up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Once I got a few points, take something straight like my D, line them all up, and make a solid line. Last step for the second inequality is I got to figure out shading. So 0, 0 is currently on the left side. So if it's true, I'm going to go on the entire left side here. If it's false, I'm going to go on away from, which is the entire right side here. Notice I'm still ignoring the blue. I don't care about this blue at all. It's this red line. We're either everything over here or we're everything over here. So if I plug in 0, I'm going to have 0 greater than or equal to 3 times 0 minus 4. Simplifying, 0 is greater than or equal to 3 times 0, 0 minus 4, negative 4. This is true. So since it's true, I'm going to shade towards the 0, 0. So looking at the red line, towards 0, 0 is this left side. Okay. I have both my problems graphed. One in red, one in blue. Now here's what we care about. I have my two problems graphed. I'm looking for where I have one shading is overlapped with the other. Where they overlap, the shading pieces, that is my solutions to the system. So I'm looking for red and blue shading on top of each other. Notice no shading here, only red up here, only blue down here, but over here, this kind of giant corner, there's red and blue. So what I do is I take a black pen, or you could even take whatever you used earlier, and I just darken in the area that I have both of my shadings at. So this is this entire space over here. So where there's overlap. What this means is any point, any coordinate in this overlap shading that I just darkened in is a solution for the entire system. So any point inside here is a solution to the entire system. If it's on the solid line, it counts. If it's on the dashed line, does not count. Okay, so any solution that is inside the shaded area or on top of the solid line is a solution. If it's on a dashed line, it is not a solution. Okay, so any of these points, if I had a point here, solution. Point over here, solution. Okay, so again, the keys are completely graph one of your inequalities and then ignore it. Don't even look at it. And then graph the second equality on top of it. And then you look for where the overlap is, and that's your solutions. And that was graphing systems of linear inequalities.